It's an honor to be presenting at the 2008 GEAR Conference to my colleagues. The title of my talk is Staying in Tune with South Florida's Water Cycle for Scientists, Managers, and Policymakers in 5 minutes per week. There is a saying that no one is an island, and I think that saying applies especially on the South Florida Peninsula. We have a pretty incredible network of aquatic scientists and professionals, and I would like to thank some of those agencies and individuals that have been instrumental behind this project, including Todd Hopkins, Kevin Coten, Cal Neerdrower, Carolyn Price, Jeff Shaughnessy, Eric Schwartz, and Susan Sylvester. And that's not to mention, too, my boss, Ron Clark, Chief of Resource Management, and our Superintendent, Pedro Ramos, who from day one have been very supportive of my multi-agency coordination efforts. My name is Bob Sobczak. I'm a National Park Service hydrologist at Big Cypress National Preserve. And for the past 10 years, every day, this is my commute, traveling between Naples, which is my home. It keeps switching. Between Naples and back and forth to Ochopee, where the Big Cypress National Preserve headquarters are. There seems to be a technical difficulty here. It keeps switching back. And when I do that commute on a daily basis, I'm enveloped by the water cycle. In the morning, it's usually sunny. And then when I leave home, this is the office at Ochopee headquarters, clouds, especially during the summer, are rising out of the Everglades. Sometimes they can be very scary. And if I make it back into Naples, I can look back to the east and see the clouds rising up behind us. Sometimes it's even raining in Naples. And I drive past water control structures on the commute. This is Henderson Creek 2 weeks ago, flowing from all directions, so sometimes the structures are flowing a lot. Sometimes they're not flowing at all. This is the S355 in Northeast Shark River Slough. And sometimes the flows are carefully timed by water managers and biologists. But from day one that I arrived here, I always looked at these structures and was mystified them. I kind of saw them as the silent sphinxes of the Everglades, and that they held the secret and the mystery of the Nile, so to speak, and the headwater source of the waters, and also provided a looking glass for looking into the Everglades, why they were built, and the data sets that were collected along with over time. So every day, for the past 10 years, I sit in my office in Ochopee and have had a chance to think about how water flows through the preserve and how the preserve, the boundaries of the preserve, are interconnected to the other watersheds of the South Florida Peninsula, and how the preserve is connected to Everglades restoration and the Everglades days of old before drainage occurred. But my brand of hydrology has always been restored or not restored, or somewhere in between. What really captivates me and keeps me professionally sharp is staying in tune with the water cycle. And I come from the north, and the continental water cycle is broken up into the seasons, where we have high water in the spring, low water in the fall, and then the storms move in from the west. Well, in South Florida, it's just the opposite. We have high water in the fall, low water in the spring. The storm clouds move in from the east most of the time. And to my amazement, we also have a hyperactive water cycle. We have summer is the flood season, then we move into the hurricane season, the drought season, followed by the wildfire season. 55 inches of rain per year, 40 of it falling during the summer. It's a pretty amazing place to be a hydrologist. And that's what led to the South Florida Watershed Journal, or fed into the South Florida Watershed Journal. It is my way, it's become a public way, and it's become one way to tune into South Florida's water cycle and view the interconnected wetlands and waterways of the Kissimmee, Okeechobee, Everglades, and Big Cypress watersheds week after week as they unfold. And I think many in this room might be familiar with the website and the weekly email reports I send out. I wanted to discuss some of just a few of the underlying principles of this weekly journal. And the first it all started out with, back about 6 years ago, was my fascination with rainfall and my realization that in South Florida you had to pretty much track it at least weekly and update data sets to figure out how things were unfolding. And that especially occurred to me in 1999. The whole southern peninsula was transfixed by Floyd. We were all looking to the east, and it was approaching. The meteorologist kept saying it was going to turn up and miss us. And sure enough, it did. It didn't really even drop any rain, from what I remember. But then out behind us in the Gulf, an unnamed storm, actually it was called Harvey, but a smaller storm just sprung up and dumped 6 inches of rain in Naples. So that impressed with me this idea of tracking rainfall on a weekly basis, staying in tune, in rhythm with the water cycle as it unfolds. Fortunately, as Matt Patterson has pointed out to me, we're very fortunate in South Florida to live in such a hydrologically data-rich environment through telemetry, using helicopters to go out and maintain sites and the historic data that comes from them. And this is an example of one of the data sets you can click into in the journal with a few clicks of the mouse. And this is rainfall for the Big Cypress Basin made available numerically by the South Florida Water Management District Meteorology Division. And again, this shows, just to run through it real quickly, and this is updated through Sunday. It shows weekly rainfall, monthly rainfall. The white bars are the average. The blue bars are the current year. You can see July, we're above average. June had a late start, but we ended strong, so it's average. And then down here is yearly. And my wife is a big Pippi Longstockings fan, and that's what I've modeled this graph after. This shows wet season and dry season rainfall. Cool colors are wet season months. The dry season are the hot months. And you can go back and look at individual months or the wet season or dry season as a whole. So it's a powerful, exhaustive, but easy to read way to look at rainfall data. But not only for the Big Cypress, looking at rainfall in Lake Okeechobee versus the Big Cypress. This graph shows rainfall for 2007. For 2 consecutive years, Lake Okeechobee got around 30 inches of rain. The average is 42, but that's a lot lower than the averages for Miami-Dade and Southwest Coast, which are closer to 55 or 60. So that leads me to the next underlying principle of the journal, which is comparing visual aids, oranges to oranges. Got 2 oranges here. And what do I mean by this? This is actually taken in Naples at Oaks Farm Country Store, the grocery store, is a water level by itself a number by itself doesn't mean anything. You have to put it in front of another number. And the same applies for water levels. Water levels don't mean anything unless you can translate them into formats that make sense. Ecological thresholds, operational thresholds, flow thresholds. And the example I wanted to use was Big Cypress. We have a number of habitat types. We have our deep water refugia flooded 10 to 12 months per year. We have our swamp apple forest flooded 8 to 10 months per year or so. Then we have the cypress. That's about 6 to 8 months per year, tall cypress. And there's a cypress dome. We also have cypress strands in the preserve. Then we have our wet prairie, usually 4 to 6 months. It's flooded per year. And then we have our uplands, pine uplands. And these are beautiful places. This is actually tobacco roots and mountains. We have our pine uplands that are 3 months per year, the hydric pinelands and hydric pines, and they don't get flooded every year necessarily, and some don't get flooded at all. But it's a mosaic. You know, where is the wedding front in that mosaic at any time or place, and how long has it been there? And I've tried to transfer that mosaic into this cartoon. So you have the giants at the edge of the water that rise up out of June. Then in July, it rises up into the wet prairies. By October, it's up at the pinelands. And then we have our sheet flow moving through, sending water down to Everglades National Park. Then in November, December, it drops down. February, March, April, it's completely dry. We get a lightning fire, and it starts all over again. So the water cycle, and then translating that into this sort of graphic where you can see the color coding represents the different ecotones, and you can see the current year, 2008. As of Sunday, we have our water wetting front up in the hydric pines, and you can compare that to previous years or the average year, and you can look at hydroperiod durations. And again, this is water depth and wetting front location, and this is water depth is in feet, and this is the 9 or 10 months when we traditionally have water on the surface. Well, and of course those ecological criteria have to be changed if you're in the Everglades. You use ridge, slough, tree islands, other ecological parameters, which leads me to the next founding principle of the journal, which is being able to connect the event horizon as data is unfolding to the historical parade of data that came before, going back all the way to the 1930s, even before in some cases. And the traditional way to do that is with a line hydrograph. This is Lake Okeechobee's current stage as of Sunday. We're still below 11 feet. And this is 2008 right there. You can compare it to previous years, 1983 El Nino years, 2007. And that's the traditional way to display the data. What I've come up with is called this hydrologic calendar. And I call it a poor man's data dump because it throws all the data up on one screen. And you read it like a book from 1940 down to 2010, and then the months of the year from January to December. So anywhere that it's a dark blue is where it was 17 feet or higher stage. Anywhere that it's light blue or dark blue is when the littoral zone was fully flooded. Anywhere you don't see a dot at all is where it was below 11 feet. So biologists, ecologists in the room, this is a handy way to look at some pretty complex data and see that historical record and to make some fun analyses out of it. For example, it's now been 500 days that the lake has been below 11 feet, and that milestone was just passed on July 23rd. So that's been fun to track. And you can do it for other parameters as well, including flow. This graph shows flow going into Everglades National Park across Tamiami Trail from 1978 to present in millions of acre feet per year. The green is Big Cypress National Preserve. The light blue is the S12s, and the dark blue is the L29 culverts. And that data can be converted into this sort of hydrologic calendar where, if need be, you could go into particular years and really see how the flow occurred through those structures. Not just water levels, not just flows. You can also do it for birding habitat. The Cape Sable seaside sparrow. This translates the data that the Corps has on the web into this visual representation. Again, 1975 to 2010, January to December. Anywhere that it's dark blue or black is where all the nesting habitat was flooded. Anywhere there aren't any dots or the warmer colors shows that there's more habitat available. So even temperature. I've done this for the historical timeline of temperatures at Naples Daily Airport, 1940 to 2010. And these things are updated weekly. So you can see that we haven't had a day at Naples Airport below 30 degrees since 1989, but January of 2003 was an extraordinarily cold month. It never had any deep dives in the temperature. So it's a very powerful way. In closing, this is the Big Cypress National Preserve graph we looked at earlier, represented in this hydrologic calendar format. And again, the color coding is the pinelands are orange, the prairies are yellow, the cypress are green, the swamp forests are blue. So you can look at hydroperiod duration and depth over particular years. So it's a way to become an instant expert hydrologically. Just click into the site, and these are what I call poor man's data dumps, and translated in those numbers into informational formats, ecological thresholds that are easy to wrap one's head around and good for biologists and ecologists and hydrologists to talk together. The other underlying principle, the third underlying principle is when I first started this off, it was kind of Bob's hydrological control room for understanding the hydrology as it unfolded in the Everglades. But it quickly occurred to me, I had an evolution in thought, that, what unites us as a community, especially something as geographically as diffuse a community as the greater Everglades? Well, often a sports team. Ronnie, it would be the Gators. So a lot of us, it would be the Miami Dolphins. For me, Baltimore Colts. Grew up with the Colts. So what if we could do the same with the watersheds? To track the watersheds as the water cycle unfolds, like we follow our favorite sports team in the sporting page or in the financials, whatever your favorite is. It turns out that 1 acre of a football field is a good unit of measurement for looking at flows and making flows comparable oranges to oranges. And the example I wanted to use with this is the S79. And again, this is a couple clicks away. I update it weekly on the website. It shows flows through the S79 from 1978, or that's 1983 to present. The full blue line is the full year, whereas the red is the year to date. In this case, it's the first half of the year. So you can see in 1998, most of the flows that went through the S79 were in the spring, whereas for the previous high flow years, Wilma, most of the flows came through in the summer as a result of hurricanes. Past 2 years have been extraordinarily dry in comparison. What if we do the same in the same format for the S12s? So you can see it's a good way to compare these oranges to oranges, flows to flows, in a fun way that's a few clicks away. So we can use the stadium model as a hydrologic yardstick. In the case of a baseball diamond, there's 2 acres in the fair play of a baseball diamond. Turns out the Empire State Building, based on the Empire State Building, is about 2 acres as well. 2 acres, I'm sorry. So I always hear comparisons of how many billions and gillions of swimming pools of flow went through the S79. I think it's much more intuitive to think about it in terms of a baseball diamond and floors on the Empire State Building. The other thing, in comparing this, celebrating the watersheds as kind of as a sports team or stadium, is for comparing our watersheds to the National League of Famous Watersheds. What if we go for a road game and compare our giants, which are 80 feet tall, to the Redwood Giants, which are 4 times as tall as our giants, which are 4 times after that the height of the Empire State Building. And I guess what I'm trying to say here is to make a reference to how much annual flows are going through the Caloosahatchee, the red, our giant of flows, to the Apalachicola, which are about 20 million acre-feet per year. The Caloosahatchee, in comparison, is about 20% of that, and then the Mississippi is obviously much bigger. But it's nice to have this sort of data. I believe that all hydrology is comparative at some level. And again, Hoover versus Hoover, again, going to the National League of Watersheds. Lake Mead has dropped over the past decade, year after year after year, 10 feet per year. Why is that? The American West has a ton of places to store water, but not much rain. Take away the snowpack, and 3 minutes, perfect. Take away the snowpack, and the level drops. Where in Lake Okeechobee, South Florida, we have a lot of rain, but no place to store it. So all it took was 2 years of drought, 2 years of 30 inches of rain for it to drop down 7 feet to a record drought. And so finally, the final model the final principle of the journal I wanted to talk about was, weather gets a bad rap. We always say we talk about weather when there's nothing else to talk about. You go to the barbershop, you sit in the chair, it's the first thing you talk about is the weather. But weather is interesting to talk about. The other model is the ivory tower model. It often gets embedded in all these journals. What I wanted to do with the South Florida Watershed Journal was kind of combine these two, have the numbers and the rigor of the numbers, but also feed in some metaphors, like the flipping of the switch when the wet season starts is like flipping a switch in the sky, giant switch in the sky, and then our wet season starts. And that usually starts when, using our calendar, nighttime dew point, or the nighttime low temperature, rises above 70, 71 degrees consistently. Then we go into our soaking in season, where you can't tell a rain cloud from a fire cloud in June. Then we're on the lookout for our 4 meteorological horsemen that bring our very scary rainfalls. They would be the enhanced sea breeze, the continental front, the Cape Verde, and the tropical tempest. And recently, in Naples, we had a tropical tempest, an unnamed storm that dropped 6 inches of rain in 3 days. And then finally, comparing the water cycle to the fable of the hare and the tortoise. In South Florida, the hare is rainfall. It sprints ahead during the summer, but for 365 days of year, evaporation, the turtle, moves along day after day after day and overtakes the rabbit at some point. And in fact, we have a faster turtle than most areas because we're so far south. The turtle does slow down in December. So finally, who's reading this? Who's reading the Swamp News? Here's Web Trends. This is from June of last year. Currently, there's about 1,500 people per month who click into the website. I can use this using Google Analytics. It doesn't tell me who's clicking. It just tells me what servers, primarily in the United States, although Vladimir Putin might be clicking in Russia. And then primarily United States, Florida. And this shows the time, and then this is the Florida-wide distribution. And this leads me to this idea. This is a powerful way to share information, to celebrate, illuminate a system, to bring us together, and to have fun with the numbers as they unfold, because we all know numbers are fun. And primarily in Naples. And here it is currently in 5 minutes. We said at the title, not quite. It's like 3 minutes, 1 minute, and that varies. So not quite 5 minutes, but we're getting there. Thank you for your time. And tune in to the site. That's the web address. And the site's set up that you can go to the front cover to get a general treatment. Essentially, it's a blog. I call it a journal because that's more professional. But you can also drill down to a database that has the data in much more detail if you have to get to those hydrologic calendars or other data sources. So thank you for your time.